Good evening, friends. This is Manish Khandelwal. I am a mechanical engineer, and the details of my experience are mentioned at the bottom of this slide. It was a proud moment for all of us when ISRO, Indian Space Research Organization, launched a spacecraft Chandrayaan 3 to Moon few days back. I prepared a presentation on Chandrayaan 3, which is including some basic information about this mission. As I communicate every time, I am running two YouTube channels. One is Factory Forward TV, where I post presentation on technical matters for most of the time. Presentations on few other areas like travel are also posted on this channel. My other channel is Brainy Builders. This channel is for the children. I shall be posting this presentation on Brainy Builders also after modifying. If desired, I shall translate this presentation in Hindi as well. Before I begin the presentation, I would like to acknowledge and give thanks to ISRO website, from where I have taken some information and pictures required for this presentation. So what is a satellite? A satellite is an object which orbits another object in space. The satellites can be of two types. One is natural satellite and another artificial satellite. Natural satellites, as mentioned, are formed through natural process such as collision of objects in space, and Moon is the best example. We can see the Moon is orbiting around Earth. This is Earth and this is Moon. It orbits around Earth, and this is a natural satellite. The artificial satellites are man-made and they are intentionally placed in the orbit. For example, Chandrayaan. And the purpose is weather forecast, communication, research, etc. The Moon takes around 27.3 days to orbit Earth. To understand the further presentation better, please note that there are three important parts of Chandrayaan. One is orbiter, which is normally placed at the bottom. Second is lander, and third is rover, which is inside lander. The orbiter remains in Moon's orbit and collects the data, whereas the lander is supposed to land on Moon. Once it will land on Moon, the rover will come out from lander. Both lander and rover are equipped with very important instruments to provide desired information to scientists at ISRO. Here is the brief history of satellites sent by India to Moon. The first is Chandrayaan 1. It was launched in October 2008. This satellite was having only orbiter, no lander or rover. The mission was very successful. The orbiter ceased the contact after 312 days in August 2009. It confirmed the presence of water molecule on lunar surface. The Chandrayaan 1 provided a lot of important information to us. Second mission, Chandrayaan 2, the satellite was launched in July 2009. Here we sent orbiter, lander and rover, all these three. The name of the lander was Vikram and rover name was Pragyan. The orbiter could be placed in Moon's orbit and it is still there. It is still sending important information to scientists. However, minutes before landing, the lander lost contact with ISRO. Now, just few days back, Chandrayaan 3 was launched. Again, we have sent the lander and rover, but this time orbiter we have not sent because orbiter is still working. We have sent a propulsion module with this. So this mission life is just 14 days. As I said, orbiter, of course, this is not a part of Chandrayaan 3. It is still working, which was sent with Chandrayaan 2. This is lander. Of course, it is responsible for soft landing on moon. Once it is landed there, then of course rover, this is rover placed inside, this will come out. What are the objectives of Chandrayaan 3? One is of course to study the moon surface and atmosphere and expand our knowledge. Second, of course, is potential areas of interest for future exploration. What all can we do in future? Then search water and other valuable resources. The traces of water were already searched by Chandrayaan 1. Then of course we will demonstrate our space technology and advance global scientific knowledge about moon. So these are the main 5 objectives of Chandrayaan 3. Have you ever thought how the satellites are reaching moon? To reach moon, the satellite has to leave Earth. A vehicle which is also popularly known as a rocket is used to launch the satellite into Earth's orbit. After achieving desired speed, these satellites leave Earth and reach moon. India's first satellite, Aryabhat, was launched in 1975 using Russian launching vehicle. However, in 1980, we developed our first launching vehicle, which was known as SLV, Satellite Launching Vehicle. This was able to establish the satellite in low Earth orbit. This launching vehicle is of course retired now. In 1993, we developed much improved launching vehicle, PSLV, Polar Satellite Launching Vehicle. This was having much higher payload capacity and it was able to establish the satellite in much advanced orbits. This is still in operation. In 2001, India developed another launching vehicle. This is Geo Satellite Vehicle, GSLV, which is using 3 types of fuel: solid, liquid and cryogenic. The payload capacity is also now up to 5 tons. The launching vehicle can establish the satellite in geosynchronous orbit. This is an orbit in which satellite moves around the Earth at the same rotational speed as that of Earth. That means satellite appears to be stationary. So as I said before also, Chandrayaan 3 has got 3 important parts. This is the combined unit. The lower unit is propulsion module. Of course, if propulsion module is not there, then normally orbiter is placed here. But since orbiter is already there in moon orbit, we have sent only the lander and rover this time. At the bottom we have put propulsion module. This is the lander and rover. This lander and rover are expected to land on moon, and once it lands, it will open and the rover shall slide from this ramp. We'll see how rocket GSLV LVM-3 M4 functions, which has carried Chandrayaan 3 up to Earth's orbit. If you see the main part of the rocket, it has two boosters on the sides which carry the solid fuel. Then the middle portion of the rocket which carries the liquid fuel. A bit narrow third stage comes thereafter, which contains cryogenic fuel. And then the front part of the rocket which carries satellite and payloads. As mentioned, this rocket has 3 stages. This means the fuel shall be burned in 3 stages. In the first stage, which is also called S200, the solid fuel is burnt. The solid fuel is stored in the side boosters, and each booster carries around 200 metric tons of solid fuel. But combustion of the solid fuel after ignition is not possible. It is like the Pavlik cracker, which after ignition cannot be controlled. So here the combustion is not controllable. Now comes to second stage. This is also called L110. Here we have liquid fuel and the oxidizer. The liquid fuel is burnt in presence of oxidizer in a combustion chamber. Here the combustion can be controlled. The weight of the fuel here is around 115 metric tons. Cryogenic fuel is burnt in the last stage, that is the third stage. This stage is also called C25. Combustion of cryogenic fuel is most efficient actually. However, controlling the oxidizer, that is liquid oxygen, and fuel, that is liquid hydrogen, is very difficult. Both these are stored at extremely low temperature. Liquid oxygen is stored at -183, whereas liquid hydrogen is stored at -253 degrees centigrade. In front part, we have the Chandrayaan satellite with its payloads. The main dimension of the rocket, the height is 43.5 meters, the diameter is 4 meters. The total weight of the rocket, including the weight of the fuel, is 642 metric ton. Friends, this table is giving the time elapsed after the ignition, the altitude and the velocity after each stage. You can see after in less than 17 minutes actually, the satellite has been launched to Earth orbit, and that time the velocity was 10.26 kilometers per second. You can imagine the speed. The above values are taken from ISRO website and for reference purposes only. Understand the different stages of rocket in a more clear way. The first stage is the ignition in the solid fuel, that is stage 1. So here S200 ignition is taking place. After around 112 seconds, the liquid fuel in stage 2 shall be ignited. L110 stage 2 shall be ignited. 15 seconds after L110 ignition, that means 127 seconds after S200 ignition, the boosters shall be separated. That means these two sides boosters shall be separated. After that, the payload covers shall be separated. Now we can see the Chandrayaan. Next stage is the main body separation, where the liquid fuel was stored. So L110 stage shall be separated. Now we are left with cryogenic fuel storage and the satellite. Finally, the cryogenic fuel storage place shall be shut off, and it will launch the satellite to Earth orbit. So this is the satellite. In Chandrayaan 3, this is propulsion module, as I said before also, and this is the lander. The rover is inside the lander. Let us note few important events in mission Chandrayaan. On July 14th, Chandrayaan was placed in Earth orbit having perigee 170 kilometers and apogee 36,599 kilometers. Perigee actually is the point which is closest to Earth, whereas apogee is the point which is farthest from the Earth. The propulsion module is firing from time to time to take the satellite farther from Earth and gain escape velocity. If you see the picture, this picture has two modules. One is the lander module on the top. This is a separate lander module, and on the bottom is the propulsion module. This combined unit is orbiting the Earth. The propulsion module, as I said before, also fires time to time to achieve higher velocity and altitude. The combination of propulsion module and lander module returns to Earth due to gravitational force, Earth gravitational force. Till such time, the gravitational force is sufficient to pull the satellite back, this satellite shall remain in Earth orbit. So for example, the unit is coming here, propulsion module is firing, it is going in this orbit, then reaching further, but if it is reaching up to here, the gravitational force is sufficient to pull it back. A stage will come when the gravitational force is not enough to stop the module and it will escape the Earth orbits. The velocity at which it escapes the Earth is known as escape velocity. The value of escape velocity is 11.2 km per second. That means if an object is having a velocity of 11.2 km per second, it will escape the Earth gravitational force. And the trajectory which the satellite follows to reach to moon is also known as lunar transfer trajectory. Once it reaches to moon, it establishes the propulsion module and lander module into the orbit of 100 by 100 kilometers. Here the propulsion module will get detached. Now only lander module is there, which will slow down and land on Earth. The expected time of satellite on Earth module is around 40 days. That means till 23rd of August it will remain in Earth orbit and then it will escape. And expected time on moon orbit shall be around 13 days. So that means till around 5th of September it will be in moon's orbit. If you see this animation, this is the satellite, for example, the yellow color one, and it was orbiting the Earth. This orbit, then further orbit, and then of course it escapes. This is the lunar transfer trajectory and it escapes to moon. So this is the end of the presentation. You may subscribe my channel if you have not done so to get the presentation faster. Thank you.